Quattro is the sub-brand used by the car brand Audi AG to indicate that all-wheel drive technologies or systems are used on specific models of its Audi automobiles. It is also Audi's actual performance division alongside S&RS. The word Quattro is a registered trademark of Audi AG, a subsidiary of the German automotive concern, Volkswagen Group. Quattro was first introduced in 1980 on the permanent four-wheel drive Audi Quattro model, often referred to as the Air Quattro. The term Quattro has since been applied to all subsequent Audi AWD models. Due to the nomenclature rights derived from the trademark, the word Quattro is now always spelled with a lowercase q, in honor of its former namesake. Other companies in the Volkswagen Group have used different trademarks for their 4WD vehicles. While Audi has always used the term Quattro, Volkswagen-branded cars initially used Synchro, but more recently, VW uses 4Motion. Angstrom Coda simply uses the nomenclature 4X4 after the model name, whereas Seat uses merely 4. None of the above trademarks or nomenclatures defines the operation or type of 4WD system, as detailed below. Longitudinal systems. Volkswagen Group has been developing four-wheel drive systems almost since its inception during the Second World War. The Volkswagen Car 1/4 Bellwagen, Volkswagen Schweinwagen and Volkswagen Kommandwagen were all military vehicles which required all four road wheels to be driven, the latter being a 4WD Volkswagen Beetle. Their military and four-wheel drive experiences later aided them in designing the Volkswagen Iltis for the German military in the 1970s. The Iltis utilized an early form of 4WD, which would later become synonymous with Quattro. Locking center differential in that original Quattro system, later found in road-going passenger cars, the engine and transmission are situated in a longitudinal position. Torque is sent through the transmission to a mechanical center differential which apportions the torque between front and rear-driven axles. 4WD was permanently active. The Torsen T1 center differential after 1987, Audi replaced a manually locking center differential with the Torsen Type 1 center differential. This allowed engine torque to be automatically directed to individual axles as driving conditions and grip warranted. Under normal conditions, torque is split between front and rear with a default 50-50 distribution in many, though not all, versions. In adverse conditions, a maximum of 67 to 80% of the engine's torque can be directed to the front or rear axles. The fully automated mechanical nature of the Torsen center differential helps prevent wheel slippage from occurring, by diverting torque instantly, without any discernible notice to the vehicle occupants, to the axle which is more grip. This method of operation can be described as proactive. Furthermore, unlike the various types of electronically operated differentials, Torsen has no requirement for electronic data, from sources such as road wheel speed sensors. It therefore has an element of fail-safe, unlike designs such as hold extraction, should one of the wheel speed sensors develop a fault. In comparison, viscous coupling, and electronically controlled center differentials that are used in other four-wheel drive systems are reactive, since they only redirect torque after wheel slippage has occurred. The advantage is felt under hard acceleration, including whilst cornering, since the torque transfer between axles is seamless, thus maintaining stable vehicle dynamics, and considerably reducing the chance of losing control of the vehicle. The Torsen-based Quattro system also offers an advantage, in the opposite function of distributing torque to the road wheels, namely engine braking. When engine braking is used to slow the car down, with Torsen-based systems, the resulting reverse torque loads on the front and rear axle are equally stabilized, in exactly the same way that engine propulsion torque is apportioned fully mechanically autonomously. This allows the spreading of the engine braking effect to all four wheels and tires. The Torsen-based Quattro-equipped vehicle is able to execute a more stable high-speed turn under deceleration, with less risk of losing control due to loss of grip in the front or rear axles. This configuration of the Quattro system, however, does have some limitations, with placement of the engine and transmission assembly in a fore-aft position. The front axle is placed rearwards behind the engine, which leads to the criticism of some Audi vehicles as being nose-heavy, though the system still leads to better weight distributions than transverse-mounted engine packages as in Mitsubishi's and similar cars. This allows for a better weight distribution of 55-45. The nature of the torsion is akin to that of a limited slip differential in that, rather than actively allocating torque, it supports a torque difference across the differential, from the side with the least grip to the side with the most. Hence by nature the torsion is limited in the amount of torque that can be supplied to the axle with the most grip by the torque available at the axle with the least amount of grip. Therefore, if one axle has no grip, regardless of the TBR, the other axle will not be supplied substantial torque. In the extreme, for a center differential implementation, complete loss of traction on a single wheel will result in very limited torque to the other three wheels. Audi responded to this limitation for the first torsion-equipped cars by adding a manually locking rear differential and then later replaced this feature with electronic differential lock, which is the ability to use the individual wheel brakes to limit individual wheel spin. EDL was implemented across both front and rear differentials to operate at speeds